Good afternoon to the August gathering. We are into the final session of the 2 days International Conference on Recent Trends in Computer Science and Engineering 2014 being organized by Department of Computer Science, Central University of Bihar. For this, we have Dr. Samrat Mondal in the chair to chair the session and Mrs. Smita Roy as the co-chair. Dr. Samrat Mondal, Assistant Professor, IIT Patna. He has done his PhD from IIT Kharagpur. His research areas are security and privacy, modeling and verification, database, software testing. Under him, 3 PhD students are enrolled. He has over 15 publications to his name. He has been invited to deliver a talk on access control system at Faculty of Technology Management, CPT University, Ahmedabad, and on password-based authentication schemes, safety and usability analysis at 8th International Conference on Information and System Security, ICISS 2012, IIT Guwahati. Mrs. Smita Roy, Assistant Professor, Central University of Bihar, currently pursuing PhD from IIT Patna. I would like to request Mrs. Smita Roy to welcome our session chair with a bouquet and a memento. The first person to present his paper is paper ID 27, Sanjay Kumar Srivastava.
Myself, H.K. Srivastava from Valmi Patna, and the topic of the paper is Evolving Predictor Variable Estimation Model for Web Engineering Projects. We are the authors, and this is the abstract. Let me begin with the abstract. Web cost estimation has not received much attention. It is region of failure of a number of web projects. Early web cost estimation can save disastrous situation. The reviews of previous work done in the field of web estimation, like size measures by Cordray, Mendes et al., Rowley and Cleary, investigates Mendes early web cost model applicability on the Indian web-based projects involving predictive variable estimation model developed for web projects.
The first paper is the implementation of parallel genetic algorithm using message passing interface. It will be presented by Lokendra Singh.
Estimation model developed for web projects extending Mendes model with risk management profitability issue, and uses curve fitting methods and sums of exponentials using Froberg's method and Moore's method. The keywords are size metrics, size measures, metrics, early web cost estimation, Tuku benchmarking project, multivariate regression, and curve fitting by sums of exponentials. Internet, as you know, is the greatest invention it is said to be the greatest invention of the 20th century. It is an acronym for Internet work. It is a network of computer networks we all know that may be linked to disembarked and joined together by means of gateways that handle data transfer and conversion of messages from sending networks protocols to those of the receiving network. World Wide Web, or simply the web, is a total set of interlinked hypertext documents residing on the Hypertext Transfer Protocol HTTP servers around the world of Internet, and web pages are written in HTML and are identified by URLs. You know very well. Let us begin. What is web engineering? Web engineering is an application of the principles of mathematics and science in order to create and utilize the web pages efficiently and effectively. Web engineering projects are concerned with the web applications, web apps, in short, development, economically timely and with least efforts as far as possible. The need of the hour is to evolve cutting-edge estimation methods and techniques to deliver accurate estimates of size, effort, schedule, and cost of software development projects to meet the competitive needs of the business environment. There has been driving trends towards the development of the network-compatible web engineering projects, catering to the needs of the multinational corporations in the area of business globalization. The time has come for insight and in-depth study for analysis in the factors affecting the web-based estimation projects. Emergence of web as a delivery environment. It has catapulted both the commercial and the educational web application development. The software development industry lacks a uniform and standardized development methodologies. The scarcity of data sets relating to the web project's development history and lackadaisical approach of the web development industry as the reason behind the scarcity of research in web application development project management. You know, the companies are not very cooperative when it comes to piping their own data about their development cost and other such parameters. The paper has been organized in 4 parts. Let us begin with the survey of the previous work done in the field of web cost estimation. There are size measures by Cloudera. It uses web application, web page, media and programs as variables. Size measures by Mondal HL. It uses hypermedia application, web application, media and program as their parameter. Size metrics by Rollo. It uses IFPUC, MKSI, Cosmic FFP. Other function points based models. Size metrics by Clear uses web hypermedia application, web software application, web pages, and size measure by Refer uses an equation V is equal to n log 2 base n is equal to n1 plus n2 log 2 n1 plus n2. Then let me begin with the Mondal's early web cost estimation model because it forms the basis of my extension in this model. Mondal used the first survey. It used online web projects to web project price quotes forms and used data from 133 companies. Surveyed 2 matrices emerged. Total number of web pages 70% company uses and features functionality 66% of the company uses. Then she made the case study with validating the results obtained from the survey and she identified web application static metrics and web application dynamic metrics as the 2 important parameters on which the web cost estimation can be done. And to validate the results, she used a second survey. In this, the target population was the web companies in the New Zealand and estimated effort for their web projects results validated finding of the first survey. Then it created Tuku benchmarking project. In 2000, by 2006, it collected data from 67 web projects from 25 web companies in 9 different countries. Let me have some introduction with what the Mondal's early web cost model, estimation model is. It is using so many variables in a stepwise regression, and it has, by using so many variables, it has derived this equation for total effort is equal to 8.69 into new web page plus 1.453 into total number high functions plus 1 into 0.671 into e to the power 0.239 into development team, where total effort is the total effort in man hours. A new web page is the new web page. Total high is the total high function. Dev team is the size of the development team, and where there is no use, web page is the same as the new web page. Now, I conducted the applicability verification survey on the Mondal's early web cost model, whether it equally follows the pattern in Indian companies or not. I have obtained data from 10 projects, belonging to 6 companies. 2 companies were multinationals who were designed for 2 projects and implemented it in India, and 2 Indian MNCs who created projects for use in other countries, and 2 were the local companies so as to make the data homogeneous, and they began with some of the parameters that Mendes et al. Overlooked. The 2 important issues that they overlooked was contingency and profitability issues. And contingency means risk management. Verification survey, I conducted the verification survey of the Indian software project. 6 companies data gathered, 9 projects analyzed. 1 project was giving quite awkward data which were not reliable, therefore it was discarded. Observed values of total effort exceeded the Mendes calculated value by 10% to 30%, which was attributed to contingency and risk management. Profitability data was also gathered. However, the company were very much uncooperative in parting with their profitability data, but with sustained effort of say around 2 years, I was able to gather it, and it was found that the profit was in the range of 9 to 19% for these 10 projects. Now, by using multivariate regression to derive predictor variable estimation model, I started with the curve fitting by sums of exponential. By using this equation, then Froberg's method was used and Moore's method was used when number of variables are just 2. So the equation that comes for wave effort estimation is a1 plus e to the power lambda 1 x plus a to the power a2 e to the power lambda 2 x, where you see lambda 1 and lambda 2 can be derived from using multivariate regression on this equation, and what the results were obtained was the gross effort results 102.749 e to the power 0.41 into development team minus e to the power minus 3.4 into development team, and the current sales price was also evaluated, on the base of 2014 prices, and it came to 10043 e to the power 41 into development team minus e to the power minus 3.4 development team. It is in terms of Indian rupees. Now, what the results were obtained? We applied testing for validation, and we obtained another data from separate company and made the test case. The project ID was this, the observed values were these, and the calculated values were these. Then we found that the accuracy level in the estimation of gross effort was 3.25%, and on the average it was found that the gross effort prediction is 6.8%, the current sale price prediction accuracy is 7.6%. When we are talking about the estimates, these errors are quite negligible, can be neglected because it is early wave cost estimation at the phase of bidding or something like that, so that the clients have an idea of what will be the price and what will be the efforts. And as developers have the idea what will be their effort, and the clients have the idea what price they will going to pay for that. At least for the bidding stage, it is quite comparable. The paper highlighted the prevalence of software estimation model and Mendes wave cost estimation model in detail, and the need to extend it to more realistic by using regression and mathematical tools, and there are the evolving predictive variable estimation model for web engineering projects which would be useful for web application development projects. These are the references. And this is the end of the paper. Thank you. Any question? Particularly from the students? Contingencies. You see, contingency is risk management. Mendes actually neglected the issues like profitability and contingency. Contingency means cost of risk management. And therefore what results he obtained and her team obtained was in the lower side. And it was found to be if applied to Indian companies, between 10 to 30%. And I investigated whether there is any relationship between risk management and profitability, and I have derived this model. Of course, it is based on just 10 companies because the companies were not so much cooperative with providing their data. Although I have contacted around 25 companies, small, big and medium all, consistently for the last 3 years. But I have been able to obtain just 6 companies' data on, say, 10 projects. The results are based on those studies. Okay. Okay, you see, in web, their pages are dynamic also. It is in software, in common software, the pages are not dynamic, they are static. So additional parameter of dynamic pages comes into the web engineering, and if evaluating their effort has not received much attention. So I have done some work. The strategy. I am also in the process of procuring more data from Indian companies.
Is not
In the next phase, I would like to gather data from international projects and generalize whether there is any relationship in Indian companies and
why the
other
mutation has
countries'
been done
companies in
after
terms of cost and
repopulate.
risk management, contingency and risk management, profitability issues. But at the moment, it is confined to Indian companies. Yeah.
No.
Any more questions?
You are distributing the subpopulation to different systems, right? Repopulate global population in the sense all the subpopulations you are taking.
So very good afternoon, sir. Those who are present over here, and myself is Nilakshi. I am from Odisha, and my paper is the cognitive model of sentence comprehension. As you know that, first, what is we mean by the comprehension? Comprehension means understanding the what we perceived from the environment, know about the thing, meaning what is the meaning of that, and accordingly, as a result, will acquire the knowledge from the environment or do perform some actions.
The performance is decreased.
Sorry? The communication is the activity of conveying information from person to the person, or any human being wants to communicate. They use it can be of the purpose for the exchange of ideas or the facts, feelings, what we are to the persons who are in front of us. So when the person is expressing, it is most important and the vital thing what the in front of you who is expressing, that should be understand to whom he is telling the thing. So the communication can be of any type, that may be intentional or the conventional or maybe the linguist. According to that, the communication can be taken different types of forms, that is, that can be expressed by using any spoken languages, or it can be expressed in the writtenly, or by using some sign language, which are expressed the frontals by using some gestures. Generally, the there may be the situation to express the language. Generally, we use the natural language for the expression point of view. Here, we are emphasizing on the. Now, when someone expresses the thing, where my motivation is how the baby knows. Oh, sorry. My motivation is how the baby learn more easily as compared to the elders. Whenever an infant listens to any language, he comprehends more easily as compared to one adult. Where and how all this complex information is processed. That is nothing but the smallest mystery organ that is present in our body, that is the brain. The functions of the brain are, it takes the perceive the thing from the environment and analyze the thing accordingly. After analyzing, if required, to store it in for the future use or perform some actions if required. This is the brain energy. I am skipping this one. Now that are the futures what I have done. This is the one paper by the brain language, importance of brain in language processing. In this paper, it is studied that earlier there was no hypothesis that only our left hemisphere is performing the language processing task. But the researchers found that not only the left hemisphere as well as the right hemisphere also takes part while processing a language. And also it is stated that in the bilinguals means or the multilinguals, the language are localized in the same cerebral area. This is another paper where the one memory-based approach has been modeled. Here, according to the functions of the brain, it is divided. It is segregated the brain functionality as in four types. Those are the sensory buffers, short-term memory, long-term memory, and the axon buffer memory. This is another paper where the sleep need of the sleep is expressed. That is in the sleep, the long-term memory is updated for the future. Generally, this long-term memory is analogous to as the permanent memory. The sensory buffer memory is used as an input buffer. When someone perceives the thing, that will be first stored comes to the sensory buffer. After that, it will go to the short-term memory, which is there, according to the researcher, it is very small and only for the 24 hours it persists. So for the future, within a day, the perceived thing will be deleted. So for the permanent storage, the long-term buffer memory are used. And to perform the axon buffer memories are used. This is another paper where the two different types of architecture, cognitive architecture has been studied. One is the rule-based architecture and the other is the connectionist architecture. In the rule-based, the knowledge is represented in the form of if and then structure. All the rules are placed in the if then structure. So when the if part is satisfied or becomes true, then it will trigger the else part, it triggers the then part, otherwise it will test for the next rule. But in the case of the connectionist, it will be, uses the neurological nodes of the computers are used the nodes of the network. And the positive constants are given to the excitatory links and the negative constants to the initiator. And the resultant will be active at the node. What is the this is the cognitive architecture. What is the comparison between different architectures that are available? Those are and I use prefer the actor as compared to the other because of it is the open source. This is the architecture of the actor, where the the four modules are used for the in the architecture. Those are visual module and the manual module, intentional module and the declarative module. And each module is associated with a buffer. So when from the environment someone passes the thing through the visual module, it will come to the visual buffer and the intention, that is the what to be perceived, what is the thing to be done. No, meaning the intentional model is used. Intentional model is used, and the intention rule will be in the goal buffer. This declarative memory is used as the functional memory, where the matching and the selection execution is done. This is my proposed model. So, from the environment, any of the sensors will be used. I have to show. From the visual sensor, no. There are different types of sensors, of the 4 different types. One are the eye, ear, skin. From the sensory device, here I take an example as an eye. And from the visual sensor environment, through the visual sensor, the percepted sentence will be first will be stored in the visual buffer memory. In short, that is written as VBM. And the visual cortex first tokenize the perceived sentence. A sentence is perceived through the sensory organ from the environment. Then the visual cortex tokenize the perceived sentence. After that, the tokens, the stop word will be eliminated and the tokens will be extracted in the visual cortex. After the elimination of the stop word, the words will be then transferred to the STM to know the meaning of the comprehend the percepted thing. From there, the STM is the very small and cannot store the longs for the words for the very long time. So it will the percepted thing may or may not get what is the meaning of the percepted thing. So it will assess the LTM, and from the LTM the thing will be here the brain map is used. I use the brain map which is analogous to the cache memory. So through that, from the LTM, the data will be transferred to the STM. First it will search in the STM. If they found the matching, then depending upon the when the match will be found, then it will there are the 2 actions. It will be stored for the, it will be directed to the action buffer memory for the function. Through the function, it will allow to the equators depending upon the depending upon the priority, the actions will be listed and assigned to the equators. And if it is not found, then again it will assess the environment for the to know the meaning of the first percepted thing. Then from the environment, it can access the dictionary or the net or ask to someone else for the meaning of the percepted thing. Now this is the implementation by using the active environment, where my goal is to know the detailed features of a person. Here in the goal worker, only I have to assign the name of which I want to fetch. Then the rules have written by using the if-then-else structure, and what is there that will be fetched and display who is the parent's name and the father's name and the mother's name. And this is another one where the input will be this is another example where the randomly 3 characters will be displayed, from which 2 are equal and 1 is the different one. When the different key is pressed, then it will display you the it is wrong, and if the correct which exists twice, if that key will be pressed, then it will be displayed. Then yes, you have to press up. This is all about these are the references. Sorry,
Paper ID 16, Ankita Srivastava. Yes.
My paper talks about a hybrid algorithm for binary topic-based text classification. Okay, so the very first thing is, what is text classification? As the word says, text classification is the task of classifying documents into predefined classes. Now these predefined classes in which you classify your document, your text, they can be numerous. Like you can have a positive class, a negative class, a class of sports, a class of politics. I mean, the classes are arbitrary and numerous. You can put on into your list whatever classes you want. Now you have a text, you read the text and you classify it into one of the predefined classes that you have. Now there are 2 approaches of text classification. The first approach is manual approach and the second one is automatic. Now what is manual approach? You take a document or you take a sentence and you read it, and then using your brain, using your IQ, you identify which kind of category it belongs or to which topic it belongs. That is manual text classification. And what is automatic text classification? That you enter the sentence into your programmer or into your software, and it automatically classifies, it automatically assigns a class to it. That is automatic text classification. So anything automatic is automatically a better choice. And this paper focuses on automatic text classification. Now, what is topic-based text classification? See, suppose you are editor of a newspaper, okay? So, by the end of the day, all journalists, they come with their articles and they submit it to you. Now, you have to decide which article is about international news, which is national news, which is sports, which is politics, which is entertainment. So, you read the entire article and then decide to which category it belongs. Say, suppose you have an article which says about W1, F1 races, which tells about Wimbledon, which tells about cricket. Then you decide, seeing these words present in an article, you decide it's a sports article. Similarly, you have some other article which tells about Katrina Kaif, John Abraham. You decide it's an entertainment article. So that is topic-based text classification, wherein depending upon the characteristic words, the specific words which belong to a particular topic, you decide to which topic that particular document or that particular text belongs. This is topic-based text classification. Now, there are 2 approaches, topic-based text classification and sentiment analysis. I just explained what is topic-based text classification. Now, what is sentiment analysis? Say you have 2 articles. The first one says about Dhoni and say Virat Kohli. So you tell it's a cricket article, it's a sports article. Now you have the next article which tells about Shah Rukh Khan and Katrina Kaif. So you tell it's an entertainment article. Now the article which was about Dhoni and Virat Kohli, it says that Dhoni is an awesome batsman and he is an all-rounder. So now when you read the sentence that Dhoni is an awesome batsman, you see the word awesome and then you decide the sentiment that is expressed in the text. That is, you're not deciding whether the sentence is about sports or politics or entertainment. You are deciding whether the sentiment expressed in the sentence is positive or negative or neutral. That is sentiment analysis. In sentiment analysis, you have the classes. So in sentiment analysis, though I cannot say they are classes, but you have say categories like positive, negative, neutral. It doesn't matter about which topic the sentence is talking. All that matters is that what kind of sentiment is expressed in that sentence. It is positive or negative or neutral, irrespective of the topic it talks about. That is sentiment analysis. And when you see about the words, the topic-based words, that is topic-based classification. Sorry. Now, the next question is why text classification? So, say I gave an example of a journalist where you have to divide things into categories. I mean, you cannot publish any news on any page. You have to divide it in categories and then publish your newspaper, you publish your article. Similarly, say we have internet. On internet, we have all kinds of news. Say all of us might be using Twitter or Facebook. On Twitter, we have all kinds of tweets which are context to any all kind of topics that are available. Say we have news about cricket, we have news about politics, we have news about weather. Now, say there is a website, Cricinfo. Now, Cricinfo corresponds to all the cricket news or the sports news that's present in the article or that's present on the tweets which are present in Twitter. Now, it has nothing to do with the politics news or it has nothing to do with the entertainment news. All it wants is the tweets which are corresponding to sports. So it has to classify the tweets and fetch out the sports-related tweets out of it. This is a simple example of text classification. Why we need text classification? Say you are in a hospital. Now you need to identify based on the prescription of the medical records of the patients. You need to identify which patients are suffering from say TB. Which patients are suffering from TB. Now depending on the medicine, the type, the content of medicine, you can decide what all patients are suffering from TB. So that is another kind of text classification, and that's why we need text classification. So there are two approaches for text classification. The very first one is rule-based approach and the second one is machine learning-based approach. Now, rule-based approach, say you have a rule, first rule, say you have first rule in your classification which says if the word Dhoni appears in your tweet or in your sentence, then you will classify your sentence as a sports word. Say this is one rule. You might be having numerous rules. You might be having hundreds of rules in your entire database or in your entire simulation. But say this is one rule. This is rule-based approach where you have rules and depending on those rules you read the sentences and classify the sentences into categories. And the second approach is machine learning-based approach. Machine learning-based approach is data set. In training data set, you tell your computer, you tell your system, see this is the training data set, if this kind of tweet appears, if this kind of sentence appears, classify it into class 1. If this kind of sentence appears, classify it into class 2. And depending on that training data set, your classifier learns and then classifies the new coming data into either of the classes. These are the two basic approaches. Now, each of these approaches has advantages and disadvantages. The advantage of rule-based approach is that, say, if you formulate rules properly, it is going to be a very accurate measure. You can classify the documents into classes very accurately if you use rule-based approach. But the disadvantage with rule-based approach is that once the number of rules start getting large number of rules, they start messing up with each other. One rule might say something and the other rule might contradict it. So maintaining these large number of rules without contradicting each other is a tough task. Now the second approach is machine learning based approach. The advantage of machine learning based approach is that if you train your classifier properly, like you have a data set and if you train your classifier based on that data set and the coming data sets, that is the testing data set or the validation data set that is coming, if it is relevant to that data set, the classifier will work accurately, efficiently. But if data that was not corresponding to that training data set, or if it has something different from that training data set, your classifier will fail. So these are the advantages and disadvantages of rule-based and machine learning-based approach. Okay, so this paper, my paper talks about hybrid approach for text classification. Now what is hybrid approach? In hybrid approach, we use both the approaches, say rule-based approach as well as the machine learning-based approach, and using both the approaches, we have developed the hybrid algorithm which inculcates the advantages of both the approaches and gives an algorithm, and when we simulated it, we found that it was actually performing better than either of the algorithms' performance individually. Okay, so this algorithm, we have implemented this algorithm, the hybrid algorithm, on threads which we collected from the site twitter.com, and we had approximately 8,500 threads in the training dataset and 8,000 threads in the testing dataset. Okay, so dataset. We had three basic datasets, three input datasets. The first was a training dataset, the second was a testing dataset, and third was a keyword set. This paper focuses on binary topic-based text classification. What is binary topic-based text classification? Is that you classify your entire document, you classify all the sentences in your document into just two categories, either sports or politics. We took here just two categories, and they were sports and politics. Like, if you read a tweet from Twitter, either you have to classify it as a sports tweet or you have to classify it as a politics tweet. Now you can scale the classes, like you can do, instead of binary classification, you can take 5 classes, you can take 10 classes. But this is a basic implementation, a binary implementation. You can scale it to whatever number of classes, n number of classes you can want. Okay, so we had two datasets, training dataset and testing dataset, and the third one was a dataset which comprised of sports keywords and politics keywords. Okay, so this is the training dataset. See, in the training dataset, this is a tweet. Every tweet has a unique tweet ID. It is an 18-minute tweet ID, and corresponding to it, we had a tag, say politics or sports. This was a training dataset, so we read each and every tweet manually and classified it into either politics or sports. This was a training dataset. Now we had testing dataset. In testing dataset, again we had the tweet and a corresponding 18-minute tweet ID, but we had no tags. We had to learn these tweets and classify them into either training dataset or testing dataset. Now this is the sports and politics keywords dataset. This is an example of politics keyword dataset. Say, what is a keyword dataset? Suppose you have a politics tweet. There are some specific keywords that belong to just the politics dataset. For example, you have Obama or you have budget. These words are, there is a very high probability that whenever these words appear, the tweet or the data you are reading will belong to the class of politics, say parliament, nation. These words have very high probability that if they come in a sentence, we will be a politics. So we had a set of politics keywords. It was around 150 keywords, and similarly we had a segment which consisted of sports keywords. They were around 140 sports keywords. Now the very first step in the algorithm, that whenever we implement an algorithm for sentiment analysis or topic-based classification, the very first step is pre-processing. Now, pre-processing was divided into two basic steps, normalization and stop word removal. Now, what is normalization? In normalization, we had three steps. The first thing, we do normalization to increase the probability that the word which is appearing, the context word which is appearing in your sentence will match your classifier, will match the words which are previously present in your classifier. So, the very first step was case conversion. Say where you have the uppercase letters, you convert them into lowercase letters, because we know whenever matching is done, uppercase and lowercase letters are considered differently. So the very first step was case conversion. Then secondly, we had removing the URLs. Say this was a tweet. Now we don't intend to go to this URL and check what was the source of this tweet. All we have to do, all we need to respond to are these words which are written inside the tweet. We have no intention of going on this URL and checking what was the source of this tweet. So the second step in normalization was removing the URLs. And the third step was stemming. Stemming is like you chop the words. Like see, we have words go and gone. So go and gone correspond to a similar thing. It's just that the tenses are different. So to increase the matching probability, we chop the words. We chop gone into go because all they convey, the sentiment they convey is same. It's just that they are different tenses. So that is stemming. Say, for example, here president, we have crossed president, we have crossed into president. Now it can be president, it can be presiding or any similar word. But this is the important thing. This is the important thing that we have to match for occurrence in a particular document. So this was stemming. Now the second step is stop word removal. Now what is stop word? Stop, say words like a, am, the, is, are, like the words which do not correspond to any class. Like they will be present in a sports data set, they will be present in the politics tweet, they will be present in the entertainment tweet. They do not help you to classify the data into any class. We remove these kind of words. They are known as stop words. Now the algorithm which we used for stop word removal in this paper was we used a smart stop word list. It's a list which is available on internet free of cost, which has approximately 600 stop words. We used that list plus some of enhancements from our own, and we used it for stop word removal. Now the data set, the basic data sets, testing data set and training data set, we implemented this pre-processing step on them, and the files which we had as output were used as input to our classifier. Now our classifier works in two steps. First one is rule-based analysis and the second one is machine learning analysis. In rule-based analysis, we have three input files. The first input file is the testing data set, the second one is training data set, and the third is stop words. Now what we do is that we take the testing data set, the set where we have to classify the tweets into either sports or politics, and we take the stop word, keywords. And then we start matching. We start with every particular tweet. We take the very first tweet and then we read the entire tweet and see how many keywords of sports keyword data set matched and how many keywords of politics keyword data set matched. And then we had a threshold value. If the number of matching crosses the threshold value, we classify the particular tweet into either sports data set, into either sports tweet or a politics tweet. So after this step, we had in the result, in the output, we had three files. The very first file was the input file that we provided. The second file was the first file was a sports keyword file, a sports tweet file. The second file was a politics tweet file, and the third file was all those tweets which could not be classified or which could not cross the threshold value which we provided. That was the third file. First file is where all the tweets which were classified into sports were saved. Second file was all the tweets which were classified into politics were saved. And the third file contained of all those tweets which could not be classified into either sports or politics using this algorithm were saved. The threshold value, so it was 0.63. It was calculated. I mean, we tried to optimize the performance of our algorithm, and we found that 0.63 was the optimum threshold value. Like it was calculated on the basis of number of keywords that could match the sports keyword dataset and that could match the politics keyword dataset, and then we used logarithms, and the resultant value that we got was 0.63, for which we had optimized performance. For 0.78 we had a similar performance, but the accuracy value went a bit down in when we used 0.78 as the threshold value. So we used 0.63 as the threshold value. Okay. Yes, ma'am. Yes, ma'am. Yes, ma'am. Ma'am, the rules are not specified in this slide. We have rules. I mean, there was just one rule that we have to read every word from every tweet, and we have to check if that word appears in either sports keyword dataset or politics keyword dataset. If it appears, you have to increase the counter. If it doesn't, just simply skip the word and move to next word. That was just the only rule, and then we have the threshold value. We match with the threshold value, the resulting value which we get from the entire analysis of tweets, and then we match with the threshold value, and if it is positive, we classify it into either of categories, otherwise. So you can convert it into rule. So it's more of condition based, yes sir. Okay. So but the rule, sir, it is also, sir, conditions are also rule. I mean, if you say, okay, yes sir. So actually the thing is that we can implement more of rules, but this was just the basic implementation, so we used just single rule. In the enhanced version, where we have used a weighted TNN classifier, it's a second paper which is published in ITNG. It's a conference in Las Vegas, which is being held in April, where we have a set of 20 rules. So that is actually rule based. This was the basic implementation. So we have just one rule that either it matches or it doesn't match. So the keywords, there was no overlapping. So they are the typical areas where you have to modify your algorithm. Okay. Okay. Yes sir. Yes sir. And sir, to improve that, to overcome those conditions, to overcome those anomalies, we have our machine learning based algorithm. We have the second phase of our algorithm, which is machine learning phase. So machine learning won't fail, because in machine learning we are not using the exact same exact same keywords. We are not using the, in the machine learning phase, we are not using the keyword data set as the basis of classification, and that's why it won't fail in the condition the previous algorithm failed. So in machine learning, we have a training data set, and then we have the output files of the previous phase as input. So if it overlaps, we will not classify it into either of categories. So how will we not know? Okay. So in machine learning phase, we used training data set and the output of the previous algorithm. So what we had as input was the training data set and the third file where we had the traits which were not classified into either sports or politics. Now we use simple machine learning algorithm. We can use either of classifiers. Here we use TNN classifier for classifying the traits which are not classified into either of categories in the previous phase, and we classified into either sports or politics depending on a threshold value again, or you can say a counter value again. And the most important phase of this algorithm is that it keeps on learning. I mean, it will not stagnate. If the, in machine learning phase also, if using the training data set, if your algorithm again has a dilemma, if it is not able to classify the tweet which we have, even using the entire training data set, if it has anomaly, if it cannot classify into classes, we will then use the two output files of the rule-based phase, that is the sports data set and the politics data set, the tweets that are previously classified. Now they come into scenario and they are used for further classification. So the advantage of this algorithm is that it never stagnates. With every tweet that you classify, the efficiency of algorithm is supposed to increase. Okay, so this is the output corresponding to every tweet ID. You get either a politics or a sports tag. And this was the validation. In validation, C1 is your hybrid algorithm, C2 is rule-based algorithm, and C3 is the machine learning algorithm. And these were statistics which we obtain accuracy between precision and recall values that we obtain after implementing these algorithms on the values that we took. We took 8500 training data set values and 8000 testing values, and on those 8000 testing values we had these statistics. Okay, any queries?